So our learning goals today, we have a couple of them over here. I can find rates of change and slopes. I can relate a constant rate of change to the slope of a line. So we were starting to do that in your exploration yesterday. So when we talk about rate of change, we've already worked with rates. When we're talking about a rate of change, that should be a constant. So we divide it out, and we should have a constant value. And what it does, it compares how much does it change, the amount of change in a dependent variable, and the dependent is first. So we're always comparing, first of all, what happened to the dependent variable, the one that was the result of something, to the amount of change in an independent variable. Because we're going to be dividing, order matters. So you can't be just, you know what, oh, just pick one of them to be the top and the other one to be the bottom, and whatever looks most convenient, that's the way I'm going to do it. No, you have to decide what's the dependent variable in the situation, what's the independent variable, and then you're going to compare them in that order over, and we're going to find this change over a specified interval. So we're going to find rates of change over specified intervals, okay? So that's what they are doing in problem number 2, example number 2 in your books. They are doing a problem where they are finding the rates of change over intervals. So would you take a quick glance at that example number 2 and tell me how many intervals did they have in that one? So they have the table with the year and the cost, the dollar amounts. How many rates of change did they find? Or in other words, how many intervals did they set up? 3? 4? 5? Well, look at step 2 in example 1. Excuse me, not in example 2. I might have said that. Example 1, step 2. From 1988 to 1990, that's one interval. How many intervals did they set up? 4, actually, right? Yeah. So they just started at the left-hand end of the table and worked their way across, saying from 1988 to 1990, there's a rate of change we can calculate. From 1990 to 1991, from 1991 to 2004, and from 2004 to 2008. Okay. So that's what we're going to do in the check it out problem number 1 below that. We have a table that shows the balance of a bank account on different days of the month. Find the rate of change. Pick up where I left off, Parker.
For each time interval, during which time interval does the balance decrease at the greatest rate?
Okay, thank you. Okay, so let's look at that table. We have day 1, day 6, 16, 22, 30. We have balance dollar amounts of 550 and 285, 210, 210 again, and 175. Okay, so the first thing we need to do before we do anything else in these problems is we have to decide what is the dependent variable and what's the independent. It doesn't matter which order you decide that in, but it matters what order you use them in. So which one would control the situation here, and which one would be the result? Would the days control the bank balance, or would the bank balance control the days? Maybe the other way to think of it is like this. Since we're going to be doing the dependent, comparing the dependent to the independent, does it make more sense to say days per dollar or dollars per day? Which one makes more sense? Dollars per day? Does it make more sense to say how many dollars there were per day versus how many days there were per $1? Okay, so dollars per day. So you know what? I'm thinking that the first thing I would do is just this. If I just figure out that label, won't that help me decide what the dependent variable should be then and what the independent should be? The dependent are the dollars upstairs, so we would say that's going to be our dependent variable. The balance that is in there, And the independent variable is going to be the day. So the number of days seems to control how much money is going to be in that balance. So first thing you have to decide is what makes more sense? What kind of a label in the end? Because this is going to be the label on every one of our rates of change, dollars per day. Okay? So this is a really important decision here. And this is where students tend to not take enough time to think about it. They just start putting numbers in, and don't worry about that answer really isn't one that makes a whole lot of sense. So when we have to find the change in the dependent, we'll start at the left end of the table and move to the next column, which is day 6. So what's the bank balance on day 1? Because the balance is going upstairs. 550, okay? Subtract, what's the balance on day 6? 285, okay? You can leave the labels out of this work. We're just finding how much did it change. How much did that bank balance change from day 1 to day 6? Well, it started at 550, it's now at 285. Day 1, take away day 6 downstairs, the number of days. So what is 550 take away 285?
265.
Okay, 265. And 1 take away 6? Negative 5. And a positive divided by a negative? Negative. Now you might be thinking you can't have negative money, but you can talk about a negative number of dollars per day. Yeah, then we're talking about it going down, aren't we? Okay, so what's 265 divided by 5? 53. Okay. So a negative 53, but that's a rate of change, so we need to give it a label. That's negative 53 what? Dollars per day. And dollars go in front of our number, not behind it. So a negative $53 per day is the rate of change over this time frame. So what does that really say then? What's happening? What does negative $53 per day really say? Yeah, when it lost $53 a day, it went down $53 a day. They spent $53 a day, took it out of there. Now, that does not mean that actually happened every single day, because if we knew what the bank balance was on day 2, day 3, day 4, and day 5, it might not be exactly $53 down every day. This is an average over that time frame. On an average, it went down $53 a day over that interval, because not all the intervals are necessarily the same length. Okay, now let's go do the next interval, day 6 to day 16. Well, on day 6, I can look back at my other one and see that it was 285 on that day. What is it on day 16? Go to your table. How much money was in the bank on day 16? 210, okay. And day 6, take away day 16. Order matters in subtraction also. 285 take away 210. Don't you use your calculators for this. Come on. 75. 6 take away 16. Negative 10. A positive divided by a negative is a negative. And 75 divided by 10, not a calculator. $7.5, which will make into money by putting a 0 there and making it negative $7.50 per day. So over that interval of time, the bank balance went up or down? Went down again at an average of $7.50 a day. Okay, go ahead and do the other two. You got this now. This is the kind of work you need to show. Okay, so what's our rate of change over the interval day 16 to day 22?
0.
$0 per day. We don't even have to talk positive divided by negative there. We have 0 being divided by something. 0 divided by anything other than itself is 0. So that's $0 per day change. Didn't go up, didn't go down. Or in the end, in that 6 days, it actually ended up the same as it started. And how about this one? What's this one? 7? I think it's 3.
Yeah.
Because it's now when it actually terminates, you can put that because here's the deal. Banks do keep it out further than a penny in the process of it sometimes. Sometimes they round, other times they don't. But this one terminates, so we'll just leave it as $4.37.5, but it's negative. Okay, so we have 4 different rates of change because they just all happen to turn out different. But each of them has their own constant rate of change over that time frame. The next question they asked is what the balance decreased at the greatest rate over which interval? Which one did it decrease the greatest at?
Day 1 to day 6.
Day 1 to day 6 right away, that very first one, that was our largest decrease. When they were paying all the belts. Okay. Each of these rates, we need to keep in mind, each of these rates actually represents an average, and I already said this, an average change. In other words, it may not exactly be, like in that third time frame, it might not have exactly been $0 every day, but one day it might have gone up $10, the next day gone down 20, the next day gone up 10, next day no change, and in the end, ended up with the same balance. So it's averaged for each day during that interval. So we talk about it as an average rate of change over that interval. The actual change may have been different, okay? Not one of those days from day 1 to day 2, day 2 to day 3, and so on. Maybe none of them make it 53, but it averaged out to that, just like your grades average out. Okay, you get good grades with bad grades, and hopefully you get more good grades than bad grades because it averages out to be good. Okay, questions on rate of change. The very first problem you do in your homework is this, and I would expect to see all of this. You have to make this decision. You need to decide what should the label be on my rates of change, because that will help you set up your subtraction problems. Write these things out, write the intervals out to help you see what is it that I'm doing. I am finding it over this interval. You need to show your subtraction problems. You need to make sure you have labels on all your rates of change, okay? All of those things are important. Any questions on rates of change before we move on to talking about how can we relate it to slope? Okay, and then let's go related to slope. So slope is the constant rate of change. So when we have a rate of change that stays constant, it just is that over the whole time frame. When we have a constant rate of change, we call it slope, but we cannot call it for a vertical line. So we say of a non-vertical line. The only lines that do not have slope are vertical ones. We cannot talk about them having slope. And we can find it by using any 2 points on the line. Since it is a constant rate of change, it does not change. That should not matter what 2 points you take. So if from day 1 to day 22 on that last problem, if every one of those 4 rates of change would have been exactly the same, we would have had a straight line with the same rate of change all the way through. It would have been constant, so it would not have mattered which 2 points we used on that line. We would have been able to find the slope. Well, this should be already familiar to you. We find slope by putting the change in the dependent variable over the change in the independent variable. That's what we were just doing for rate of change. How much did it change in the dependent over how much did it change in the independent? Well then, what are we talking about? Change in what? What variable is typically the dependent variable? Y. So we're talking about how much do the Y values change over, what do we typically call the independent variable? X. So change in Y over change in X. We always talk about how much does it change going up and down first, and then over how much it goes back and forth. What do we call that? You've heard this before. They both start with R. Rise over run. Yeah, rise over run. There's a poster over there with it, isn't there? Rise over run. Change in Y over change in X. How much does it rise or fall, you could think of it, over how much does it run? How much does it go back and forth? Okay? Slope plays a really important role in these, so we have to understand when we find slope, does it make sense to the problem, first of all. Okay, so when we have positive slope, what should we expect the behavior to be on the graph? What should the line do? What should the points do? Rise from left to right. They should rise from left to right. And note I just made a little diagram of it over there. It should rise from left to right. That's what we mean. As you look in the left-hand part of the graph and follow across the page, your line better be going up. So what's happening to the Y values? They're rising, they're increasing. So the Y values increase from left to right. So the X values are definitely, because when you move left to right, you got increasing X values. But then what's happening to the Y values? Are they going down or are they going up? They are increasing. Okay, how about the negative then? What would the negative slope do? What would happen as you go from left to right on the page? They would fall from left to right. Your line or points should be falling from left to right. And I have a little diagram there. So we're moving across our page from left to right. Our X values are increasing. What's happening to the Y values for it to be falling? They are decreasing. Yeah, they decrease from left to right. When we have zero slope, because that's our other type of slope, we have positive, we have negative, and we have zero. When we have zero slope, that means there's no change in the what? Y values. There's no change in the Y values. The Y values have no change from left to right. So what kind of a line is this called? Horizontal, yeah. So a horizontal line. The only thing changing are the X values. As you go across the line, only the X's are changing. And remember, X's are downstairs in our slope. So we need X values that are changing. Upstairs, we have our Y values. They're not changing. What happens when you have a zero upstairs and you have another number you're dividing by downstairs? What always happens? What's zero divided by anything other than itself? You get zero. So that's why the slope ends up zero, because the Y values have no change. We always have a zero upstairs in our slope. Undefined, that's when you have a vertical line. You cannot say it has a slope. It is undefined because there is no left to right. In other words, zero, X is going to be zero. There's no change in X. If zero is downstairs in a fraction, if you're trying to divide by zero, can you divide by zero? Does anybody's calculator let you divide by zero? Okay, it shouldn't. If it does, get rid of it, ask for a new one for Christmas, because it should not divide by zero. It should end up error or undefined. It should say something like that. So when we have a vertical line, we talk about it not even having slope. It's an undefined slope. One other thing we want to keep in mind about slope is not only what behavior does it have. Is it rising from left to right? Is it falling from left to right? Is it horizontal? Or is it vertical with no slope? We also talk about that slope gives us the line's steepness. It tells us how steep that line is. I don't know about you, but when I go snow skiing, I want to know how steep the run is I'm going down, because I don't do well on really steep slopes, like the intermediate ones. So here's how we measure how we can tell whether one line will be steeper than another. Especially if on the picture they look the same because the scales on the graphs were different, kind of like happened in our exploration. As the absolute value of the slope increases, oh my goodness, there's that word, absolute value again. What's that mean? What's absolute value? The distance away from zero. So you identify what the slope is and you say, how far away is that from zero? Because as the absolute value increases, the line becomes steeper. So the larger the absolute value, the steeper the line. So now, you go ahead and answer that question, which line would be steeper? A line with a slope of -3 or a line with a slope of 2? First of all, let's talk about their behaviors. What would a line that has a slope of -3, what would its behavior be on the graph? Would it rise, fall, be horizontal? It would fall because it is a negative slope. How about slope of +2? What would that do? That one would rise. Okay, so that's their behaviors. Now, which one is steeper? Why? Because the absolute value of -3 is bigger than the absolute value of 2. What is it, -3's absolute value? 3. And the absolute value of 2 is 2. 3 is bigger than 2, so so we're going to write this out in our notes. We're going to have good notes here. The slope of -3 is steeper than 2 because the absolute value of, looks like I get the word value in there, I guess. The absolute value of -3 is greater than the absolute value of 2. So I would rather climb a slope without my skis on that is steeper than go down one with my skis on that isn't. So in this case, I would choose the slope of the 2 because it's not as steep. Okay, anybody have questions on rates of change, and we can also relate those to slope, or how to find slope, or understand it. Okay, then let's get you going on your homework, but I do need to announce